In today's lesson, we'll be learning how to graph quadratic relations in factored form. If you recall, a linear relation resembles a line. There are two forms that a linear relation can take on. It can take on standard form or slope-intercept form. As we learned previously, standard form is not as useful as slope-intercept form. Because in slope-intercept form, you can easily see the slope and you can easily see the y-intercept. We've learned that a quadratic relation resembles a curved line. We call this a parabola. A quadratic relation can take on three different forms. It can take on standard form, vertex form, and factored form. We previously took a look at standard form. Today we're going to take a look at factored form. In our first example, we have a quadratic relation in factored form. What we want to do is take these values of x and substitute them back into this quadratic relation to find the values of y. And with these x and y values, we can plot these points and connect the dots and eventually create our parabola. But before we do that, we're going to have to crunch some numbers. So let's zoom in on this table of values. What I'm going to do is I'm going to substitute in these values of x. So instead of writing x, I'm going to write that number in brackets. So here I have -3 plus 1, and I have -3 minus 1. You're going to have to be very careful with your signs here. What you have is -3 plus 1, which is -2, and then you have -3 minus 1, which is -4. So -2 multiplied by -4 is +8. And I'm just going to move this over because we're going to need a lot of space for this question. I'm going to do the exact same thing with -2. I'm going to substitute -2 into x. So I'm going to put that -2 in brackets. Everything else stays the same. And over here, I'm going to put -2 in brackets, and everything else stays the same. You're going to have to be very careful with your signs here. -2 plus 1 is -1, and -2 subtract 1 is -3. So -1 multiplied by -3 is +4. Let's repeat the same process for -1. I'm going to put -1 in brackets. Plus 1 stays the same. I'm going to put the -1 in brackets. The subtract 1 stays the same. Again, be very careful with your signs here. -1 plus 1 is 0. And -1 subtract 1 is -2. So 0 multiplied by -2 is 0. Let's do the same thing for 0. 0 goes in the brackets. Everything else stays the same. 0 goes in the brackets. Everything else stays the same. So 0 plus 1 is 1. 0 subtract 1 is -1. And 1 times -1 is -1. Let's do the same thing for the 1 down here. So let's put the 1 in brackets. Everything else stays the same. 1 plus 1 is 2. And 1 subtract 1 is 0. So 2 times 0 is 0. And let's do that for +2. +2 goes in brackets. 2 plus 1 is 3. And 2 minus 1 is 1. And 3 times 1 is 3. And let's finish this off. We're going to put the +3 in brackets. So +3 plus 1 is 4, and 3 minus 1 is 2. And 4 times 2 is 8. And before I proceed, I've just noticed a mistake I've made. That should not be +4, so let me erase that. This should be +3. At this point, you have a bunch of x and y values, which when put together gives you a coordinate. So let's go ahead and plot these points. So we're going to do that on this graph over here. Let's begin with negative 3/8, which would be right over here. Our next point is negative 2, 3, which is right over here. Then we have negative 1, 0, which is right over there. We have 0, negative 1. Then we have 1, 0. Then we have 2, 3. And last but not least, we have 3, 8. And let's connect these dots with a curved line. And there we have a parabola. However, before we complete this question, let's describe some of the properties of this parabola. Down here, we have something called the vertex. However, you'll also notice that this is the point at which the parabola crosses the y-axis. So this also makes it the y-intercept. And over here, we have 2 points. These are the points at which the parabola crosses the x-axis, which makes these the x-intercepts. So we have 2 in this situation. Okay? And if you recall, the axis of symmetry goes through the vertex. So I'm going to label this AOS for axis of symmetry. And the equation for this axis of symmetry is x is equal to 0. And there's a couple other things that we can describe this parabola with. As you can see, the parabola is opening upwards. It is smiling. So we can say opening upwards. As well, you can take a look at the vertex. The vertex is located at the lowest point, which would make it a minimum value. And in this situation, the minimum value happens to be negative 1. I'm just going to put that in brackets. Therefore, we have just graphed the quadratic relation, which was originally given to us in factored form. Okay, I'm just going to make a little note that that was in factored form.